When two American astronauts descend to the unexplored plains and craters of the moon, they're not going as tourists or as sightseers of a land as yet unknown in any guidebook. The astronauts are there as working scientists. They have three scientific tasks ahead of them: collect rock samples, set up a series of lunar surface experiments, and conduct a geologic survey. They have less than 24 hours to do the job. They will use the Apollo Lunar Surface Experiments Package, or ALSEP. ALSEP is actually two packages connected barbell fashion, weighing approximately 33 pounds on the moon or 200 pounds on the Earth. They contain the 6 basic elements of ALSEP to be flown on the lunar mission. The crew will set up the experiments on the moon in much the same manner as this astronaut demonstrates on a simulated lunar surface. ALSEP will first be carried 300 feet from the lunar module to a level area. Here, the experiments will not be subject to blast effects from the module when it takes off from the moon. Also, should anything unforeseen occur, a failure in the portable oxygen system, for example, the astronaut could safely return to the lunar module using his emergency oxygen system. The red cask with the fins is the nuclear power generator. It furnishes electricity to run the experiments. The generator is fueled with plutonium-238. The decay of this isotope creates heat, and the heat in turn is converted into electricity. However, the astronauts must be wary of the temperature. The generator fins reach 500 degrees Fahrenheit at the base. But there's no radiation hazard. Plutonium-238 emits only alpha rays, and alpha rays can be shielded by a piece of paper. The generator is immediately connected to the second unit. And the first thing deployed from this unit is the passive seismic experiment. This experiment can measure violent lunar quakes as well as small meteoroid impacts. This experiment will tell us whether the moon is an active and dynamic body or is a cold, passive satellite. Next is the solar wind experiment. It measures the flow of electrons, protons, and charged particles which travel through space from the sun. We know very little about these particles. When they approach the Earth's magnetic field repels most of them, and they do not reach our atmosphere. The base of the second unit is deployed to become the central data station. The antenna of the central data station receives commands from Earth. It also transmits back to Earth data collected by ALSEP. The third experiment is the magnetometer, which measures the moon's magnetic field. From its measurements, we can deduce if the moon has a molten core, an important fact in determining the origin of the moon. The final experiment is the ion detector, which measures positive ions. We're accustomed to say there is no atmosphere on the moon. To all intents and purposes, this is true, for there is no oxygen to sustain human life. No heavy gases, such as make up our own atmosphere. But there are probably charged particles present, perhaps enough to justify speaking of a very minute atmosphere and determining its origin. ALSEP will be turned on by remote command from the ground, or the astronauts themselves can turn it on if necessary. It will run continuously, 24 hours a day for up to a year. Long after the astronauts have returned to Earth, ALSEP will continue sending its information to ground stations. Even before the experiments are set up, the astronauts will collect a quick sample of lunar rock and soil. Then later, they will go about a methodical collection of samples for detailed analysis on Earth. In addition to the rock and soil samples, the astronauts will collect special atmospheric samples. These will also be analyzed later by scientists on Earth. The lunar explorers will also conduct their geologic survey, observing, noting, photographing, bringing into play their months of geology training. The astronauts will be bringing home to us part of the moon, a part that under the microscopes of Earth will help us solve the enigma of the moon's creation.